So this hopefully short video is about parallel and perpendicular lines and what kind of things we need to do with those in terms of measuring your understanding. So there's a symbol for parallel lines. So if I say line 1 is parallel to line 2, I use these two vertical lines that are parallel to each other. If I want to say that line 2 is perpendicular to, line 1, let's say line 3 instead, then I would use this little kind of upside down T, as some people have described it to me. It's perpendicular because there's this little right angle in the symbol, so it's typically used for perpendicular. It's not really a T, it's its own special symbol. So let's figure something out here. I've drawn this line, and it goes through the point 3, 3, and it also goes through the point -3, -1. All right, so first let's find the slope of that line. M equals change in y divided by change in x. And so that's going to be, let's choose this to be my y2. So I'm going to have 3 minus -1. And I'm going to have 3 minus -3 for my change in x. And I get 3 plus 1 is 4. And 3 plus 3 is 6. And so I get a slope of 2/3. So this line has a slope of 2/3. Okay? Now, as we discussed, slope really kind of talks about how steep a line is. It has a positive slope if you're meaning you're going uphill. You're adding elevation, height, as you move from left to right. And if you're removing height or elevation as you move from left to right along the x-axis, then it has a negative slope. Change in y is the change in the vertical distance from one point to another divided by the change in the horizontal distance, that's delta x, as you're moving from one point to the other along the x-axis or the horizontal. So now that we have this line that has a slope of 2/3, if I were to look for a line or try to determine a line that was parallel to it, for instance, let's say this orange line, let's say, is parallel to this yellow one. And we'll use some symbology to identify that. Recall from geometry, we can have these little arrowheads. And so if those two lines are parallel, or if I labeled this one line 1 and this one line 2, and then it follows this notation up here, then these two lines have the same slope. So that means the slope of the orange guy, the orange line 2, is also 2/3. And that's fairly typically obvious to folks that when that's the case. But when we start talking about perpendicular lines, it's not always obvious why two lines that are perpendicular to each other have slopes that are opposite reciprocals, or what I say, negative inverses of each other. So let's draw this line here. And let's say that it goes through this point 4, 2, and it goes through this same point -3, -1. And so if I calculate its slope, I'm going to have 2, let's say -1 minus 2, and -3 minus 4, which gives me -3 over -7, which is 3/7. Now, if I had a line that was perpendicular to it, let's say this line here, it would have the following points. Let's hope this works. 2, -3, and then this point up here is going to be -1, 4. And let's find the slope of this line. Let's call this my y2. So I got -3 minus 4, and then I got 2 minus -1, and I'm going to go ahead -7 over 3. And so notice this does in fact look perpendicular. Tried to draw it that way, and then it has a slope that is the negative inverse of 3/7. Or if you prefer, the opposite reciprocal. And it's because basically instead of going, how do I explain this? in this yellow one, I'm going to change my x direction. Excuse me, I'm going to change from one point to another in this distance, this x distance. And then I'm going to change in this y distance to develop the slope. So that's going to be my delta y, this distance. And this distance is going to be my delta x. Once I do that here, note that I'm going to have 1, 2, 3, 4, 5, 6, 7. This is a distance of 7. That's now my change in y. And this distance 3 is now my change in x. So the change in y and change in x change positions. That's how you get the reciprocation or the inversion. And then it's going downward in this y direction. So this change in y becomes a negative number. And so that's why it works that way. So what kind of tasks are you going to be asked to do? Let's see. 1, you're going to be given a slope, let's say 2/5, and you're going to be asked to 2/5 and another set of points, let's say -5, 7, and you're going to be asked to write the equation of the line that is parallel to this line but goes through that point. And this is where that point slope form comes in very, very handy, because I can do the following. Since I'm given the slope, I can just write y minus y1 equals m times the quantity x minus x1, and I can just substitute the 7 in for this y1, write down the slope 2/5 and x minus x1, which was -5. And so I get y minus 7 equals 2/5 x plus 5. I'm going to distribute this 2/5 and get the following: 2/5 x plus, and it just happens in this case that this denominator is 5 and that number is 5, so they'll equal 1. So I'll get plus 2. And then when I add 7 to both sides, I end up with the following: y equals 2/5 x plus 9. That would be your final answer that the software typically wants. I would tell you that if it was a paper and pencil test, I would stop right here and allow that as my legitimate answer, because it is the same. Someone might claim it's not simplified. I would say that it's in point slope form, and it's perfectly fine. So that's point slope form, and this is slope intercept form, which is often asked for. So it's just dependent on what somebody prefers, or what they're testing you on, or what they're asking, the task. You could also be asked the same question, except I need to find the line that's perpendicular. So let's use the same numbers and find the line that's perpendicular to a line that has this slope but goes through that point. And so my original line has the slope of 2/5, and so I need to determine the line that's perpendicular to that. Its slope would be, let's call that m1 and call that m2, is going to be -5/2. And then if the point that we were trying to find a line to go through was, what was it, -5, 7? -5, 7. Then we're going to do the same thing. Again, I would use the point slope form. Y minus 7 equals -5/2 x minus, but I know from before that it's going to be plus 5. And now, when I distribute the 5/2, -5/2, I'm going to get -5/2 x minus 25/2. I paused for a second because I thought maybe I messed up the sign above, but I don't think I did. And then I'm going to add 7 to both sides because I want this to be a 0, so that I'm left with y all by itself, 5/2 x, and I'm really taking 25/2 and I'm adding 14/2. Remember, I made the denominators the same so I can add them, so I need common denominators. And so I get y equals -5/2 x minus 11/2. So that line is perpendicular to the line that had the slope of 2/5, and it goes through the point -5, 7. So there are different versions of this problem. Sometimes they give you a line and another point. Sometimes they give you 2 points and a third point. Sometimes they just give you 2 points. but it's all the same information, because if I'm given 2 points, I can calculate the slope of the original line. Okay? So that's it for parallel and perpendicular lines.